Okay, so we'd like to draw some nice graphs, but a bit of theory first. Okay, so what do we mean by increasing? What we mean by increasing is that if you have an interval, say from A to B, and you got an x1 and an x scheisse. Oh boy, that's even worse. Not starting well. Okay, x2. Okay, it just means the obvious thing. When I go left to right, my function is going up. Okay, that's what these two inequalities are telling me. Okay, and similarly, decreasing would change this inequality here. Okay, we're going to use the derivative to help us find when a function is increasing or decreasing. So this theorem is called the increase-decrease test. Okay, 1. Okay, so if f prime of x is bigger than 0 on an interval I, then, well, first derivative is positive, so slope of the tangent line is positive, so no surprise here. We get that f is increasing on I. 2. If f prime of x is less than 0 on I, then of course we have decreasing. On I. 3. If f prime of x is always 0 on I, then f is flat constant on I. Okay, you may say, well, why do I need a theorem here? This is obvious. Well, not quite. In math, we're very precise, okay? We have a definition of a function being increasing on an interval I. Okay, intervals, I forgot to mention, you take 4 forms here, one of these 4 forms. So we have a definition of f being increasing on an interval I, and then we have the notion of a first derivative being positive. Okay, these are obviously connected things, but they're not the same thing. Okay, so that's why we need a theorem. Okay, so the theorem says that if f prime is positive, then f is increasing on that interval. So how about an example? Find the intervals where f of x is equal to 2x cubed minus 9x squared plus 12x minus 3 is increasing or decreasing. So we'll use the theorem 1 there. We'll just take f prime and find out when it's positive and when it's negative. So f prime is 6x squared minus 18x plus 12. we want to find out when is this expression positive and when is it negative, because we're trying to use theorem 1. So what I'm going to do is I'm going to find out, first of all, when is it 0? Well, I'm going to need to solve by factoring. So what do I get? 6x minus 1, x minus 2 is equal to 0. So x is equal to 1, x is equal to 2. So why did I do that? Why did I set it equal to 0? Well, because look what I can do. I can make a number line. Beep, beep. Put a 1, put a 2 there. And I can say that, let's change our color here. At 1, f prime is 0. At 2, f prime is also 0. Now, everywhere else, f prime is not 0. Let's go back to black. So how about for numbers less than 1, So what I'm going to do is I'm going to take f prime, plug in 0. And what do I get? Nice faint line. Okay, taking the factored form for f prime, plug in 0, what do you get? 6 times -1 times -2, which is 12. Bigger than 0. So f prime of 0 is positive. So over here, I can conclude that f prime is always positive. Well, how do I know that? Well, because the only time f prime can change signs is, well, at 1 and 2. Okay, because if you want to change signs, you have to go through this 0 here first. Okay, so I conclude that f prime is bigger than 0 here, based on what we call a test point. X equals 0. Okay, how about if I f prime of something between 1 and 2? So you do, 1.5. And what do you get? Well, you don't want to actually calculate this. You want to go take the 6 times 0.5 times negative 0.5. I don't want to actually calculate that. I don't need to. I just need to know, is it positive or negative? And this is obviously negative, right? Single negative, so negative. So I write f prime is less than 0 here. And finally, I'll take f prime of 3, and I will get 6, 2, 1, bigger than 0. Again, not actually calculating that. Don't have to. I just need to know, is it positive, is it negative? 3 is bigger than 2, so f prime is bigger than here. F prime is bigger than 0 here. Okay, so f prime is bigger than 0, telling me that my function is increasing here, and then I have decreasing here, increasing here. Okay, this diagram, this number line diagram, is enough to answer the question. But if you want to write it down more formally, you can say increasing on negative infinity to 1, and also from 2 to infinity, right? Okay, and then we put what's called a union between them, okay, kind of like the word or. You can say decreasing on, well, what's left between 1 and 2. And there we have it. Okay, if you're paying close attention, you'll ask, why don't I include the 1 and the 2 here? Well, you could if you wanted to, but common practice is just to leave them out, and I believe our textbook just leaves them out.